going to install Vault from HashiCorp on Windows 11. Stick around until the end of the video, and I'll give you a bonus tip to more securely store your secret data in the Vault. We'll install the free open source version of the HashiCorp tool called Vault. Let's open a browser and search for HashiCorp Vault Download. We'll click the first link that says Install Vault. On the installation page, we see the latest version is 1.13.3, and it's available for a variety of platforms, including Windows, macOS, and lots of flavors of Linux and Unix. Nice to see you, Solaris. We'll be installing on Windows 11, so let's click the Windows link. I'm running a 64-bit version of Windows 11, so let's select the Download AMD 64 link. Vault comes packaged as a zip file, which will end up in our Downloads directory. When it's finished, let's click on the download and select Show in Folder. In our Explorer window, let's right-click on the download and select Extract All ... We'll accept the default destination and click Extract. That will pop up a new Explorer window with the contents of the zip file uncompressed into a directory under the Downloads folder. Surprisingly, the entire download consists of just a single executable file called Vault. Let's move that over and then drill into our C drive in the projects directory. And then in the other window, let's go up one level until we see the uncompressed directory. And simply drag and drop that into our projects directory. If we go into the folder, we see our single file, vault.exe. All right, let's close our Explorer windows and browser. Let's open a command window. We'll cd into the project's Vault directory we just created. And let's run the command vault space version. And we see that we have version 1.13.3 available to us. Believe it or not, it's installed, at least at a very basic level. We could add it to our executable path and do some other things, but for our purposes, it's installed. Let's see what commands are available to us by entering vault space server space -help. And we see lots of different modes we can run the tool in. We're just setting it up for development use. This means all our secrets will be managed in memory, so when we shut the instance down, all our information will be lost. To start our server up in dev mode, we'll enter vault space server space -dev. And we get a lot of information on the screen. The most important things we see are Vault is unsealed. This means the Vault server has been initialized and unsealed, allowing access to its secrets. When in a sealed state, access to secrets is restricted. We also see Successful Mount, meaning the secrets engine has been configured and enabled for use. We see the warning about the fact that everything is in memory and will be lost. And finally, we see the Vault adder value and something called a root token. Vault adder is the address or URL of the Vault server. The root token is a highly privileged token that serves as the initial master token created during Vault's initialization. Using this credential, you have access to all the secrets and administrative functions within the Vault system. We'll leave the instance running in this window. However, to send it commands, we'll need to open another window. Because it's not in our path, I'll need to change directories to the location where the vault.exe file is located. Right now, in our new window, it doesn't know that we have an instance of Vault running, so we have to tell it where to look. We'll do that by setting the environment variable vault adder equal to 127.0.0.1:8200, where the server is listing. Next, we'll need the root token to access the Vault. Keep in mind, we're running in dev mode. The root token would normally not be available to us or treated so casually. This should be kept confidential since it provides root level privileges on the Vault and allows us to do anything to the Vault and its secrets. For now, we'll make a copy of it and set the environment variable vault token equal to its value. Now if we run the Vault command in the second window, we're able to make a successful connection to the Vault server we have running. The command vault secrets list shows us a list of the enabled secret engines within the Vault server and their mount paths. We will focus on the KV type, or key value, which allows us to store key value pairs in the Vault. Notice the mount point for this is secret. So before we continue, let's pause for a moment and ask, what kind of data should we store in the vault? The vault is for securely storing and accessing secrets. In this context, a secret is anything you want to control access to. Such things could be API keys, passwords, certificates, and other sensitive information. Vaults provide unified access to any secret, as well as tight access controls and detailed audit logs. We'll be using the KV, or Key Value Secrets engine. Let's see what subcommands are available to us by entering vault space KV. We see lots of subcommands, including delete, destroy, get, and so on. Let's use the commands to see how we can perform the CRUD operations, create, retrieve, update, and even delete on a vault. Our first operation will be an effective create command. To do that, we'll enter vault kv put -mount equals secret my awesome app /creds dbid equals admin dbpid equals mypass01. So let's break that command down piece by piece. Vault kv put invokes the vault command. KV specifies key value secrets will be used for storage, and put is our subcommand. In effect, the put subcommand is the create for a vault. It encrypts the data we supplied and stores it in the vault. Mount equals secret specifies the mount point of the KV secrets engine. myawesomeapp /creds is the path where the secret will be stored in the KV secrets engine and allows us to refer to our secret when we want to retrieve, update, or delete it later. dbid equals admin and dbpid equals mypass01 are the key value pairs representing the secrets to be stored. In our case, we have two key value pairs to be stored. When we hit enter, we see a date for the created time. No metadata was created, the value has not been deleted or destroyed, and the version is 1. We'll see what some of this means as we continue with our example. No errors were produced, so we must have created something, right? Now let's run the command to get the data back out by entering vault kv get -mount equals secret myawesomeapp /creds and press enter. And we get the same metadata information again, but this time we get a new block called data. It has our key value pairs that we entered for our user ID and password. So the get subcommand retrieves the data for us. Because we had the root token available to us, we were able to decrypt the values and display them in plain text. Now let's see how we can update a value. To do that, we'll enter vault patch -mount equals secret myawesomeapp/creds dbid equals admin and dbpid equals mypass02. Effectively, we've changed the password for our account with this patch command. We see our metadata once again, but this time notice the version says 2. Let's recall our get command. Remember, this is the retrieve in our CRUD calls. And let's submit it. When we do, we get version 2 of our data, which includes the new password, mypass02. Let's recall that command once again, but this time we'll add an optional parameter, -version equals 1. With this, we're specifying the version of the data we want to see. Running that command, we see the original data value, and we also see the version indicating this was the first version. Let's recall that command once again and change the 1 to a 2 and run it again. When we do, we get the second version of the data, which includes the new password. What happens if we try entering a version other than 1 or 2? Let's try entering version 3. Predictably, we get an error message. At this point, we've seen create, retrieve, and update. Now let's see how to delete a secret. That command will be vault kv delete -mount equals secret myawesomeapp/creds. And we get back an interesting message. It says the data was deleted if it existed. This is the Vault's way of not telling us directly that the data did exist. The system doesn't want to tip off the bad guys that they found a valid secret. Now let's recall our get command again and run it, Notice now our deletion time is filled in and no data is provided, meaning it was deleted. At least version 2 was. If we recall the command once again and run the get command, we see version 1 of the data, including the user ID and password, are still present. Cool, so we've seen all the commands necessary to do an effective CRUD call to the vault. Now it's time for the bonus that I promised. In the create commands we run, our secrets were exposed on the command line. If someone could see our command history, they could see that our secrets were exposed. Not so secret after all, right? Let's look at how we can add a secret and not have it exposed in the command history. Let's enter vault kv put -mount equals secret my next app token equals dash and press enter. Instead of getting back a command prompt, we get a new blank line where the vault is waiting for us to enter data. Let's give our token a value of some awesome token and press enter. Still waiting. The way we can signal that we're done is by pressing Ctrl-Z on a Windows machine or Ctrl-D on a Mac, Linux, or Unix machine. And our secret looks like it was accepted and stored. Let's verify that by running vault kv get -mount equals my next app and press return. And we get back our token value, some awesome token. Alright, that's it. If you found this Intro to Vault video useful, please subscribe to help the channel grow. Let me know in the comments if you'd like to see more videos on Vault. That's all for now. Thanks for watching, and remember to always begin secure.